Alright, disappointingly, this is my fourth time recording this video. I absolutely hate using my Twitch settings. Well, first time it was because I had it streaming online, so it lagged a little bit until it wasn't good. The following time, it decided that it was going to crap out, and then the next time, I accidentally hit a hotkey to switch screens, which in effect messed up my video. So I just compiled my program. So this is for CMPS 160, Fall 2013, Lab 3 Terrain Rendering. My name is Eric Anderson. My email is eanders1@ucsc.edu. So I'm going to go ahead and get those first 5 points by running this program using the parameters provided with the starter code. I called my program L because I am lazy. L for lazy. Okay, right now you see pretty much the next 5 points, which is generate terrain geometries and provided height field map. This is the provided height field map where this is 0, 0, and on that side all the way over there is 512, 512. The texture is applied to the terrain. I did not draw this by myself. If you want to check, you can check the code. And it's certainly not one color. Option to generate face normals based on height map geometry. So all these are face normals right now. I can get the next 10 points by changing these to vertex normals. So I don't have these preloaded in memory. So these are rendered or regenerated on the go. These are the vertex normals. Looks a lot smoother. You can definitely tell. You can still see this looks like sand, like wind eroded sand. But if I turn back on face normals, it looks like shitty steps from RuneScape. Okay, but since this is 2013, our graphics need to look a little something like this. Okay? It is pretty obvious. Like this scene with one stationary light. It's not necessarily stationary, not when I start moving it, but that's what the next points are for, which move the stationary light, okay, makes total sense. So right now it's stationary, it's somewhere above the map terrain thing. You can move it along the x-axis, the y-axis, excuse me, the y-axis, and the z-axis. Voila! Controls for that are in the console when you run the program. Okay, let's put it back here. I think it looks fairly nice around here. So we just did that. Use the display list or VBO. So right now, I'm not using display list or VBOs. Everything right now is CPU rendered. So this is slow and it sucks. It's kind of chunky. You might be able to notice that. There is a hotkey here. So you hit 5 and it will turn on display list. I capped this at 60 FPS because otherwise it will go wacko on my computer. So you can take off the 60 FPS by going in and removing the sleep function that I have in there. Sleep will not work with several other OSs, but heck, I'm including Windows.h, so I don't expect you to compile this on any other system. Okay, so that's what display list's on. I'll show you my code. Here I'm creating the display list. Okay, you can look over that. Here I create it. DL is actually a global variable up here. And it calls this right here, draw terrain. Draw terrain draws all of my pretty much the entire terrain, because the terrain itself is not changing. The only thing that changes is the position of the light, which is not calculated in draw terrain. That is calculated in my display function. So right here. So right here, if not delist, draw terrain. So if delist is not enabled, then it'll draw it using the CPU. Otherwise, it'll draw it using the GPU. Okay. Add controls to change viewpoint and field of view and move around the terrain. Okay, so you can do that right here. Woohoo! Wonderful. Controls are in the console. Display a help message about what the mouse and keyboard do. That's all right here. Add options to modify the clipping planes. Okay, let's start from right there. So I'm going to start off with the far clipping plane. I'm going to decrease that and see what it does. Basically what it does is it decreases the distance that you can see. If you have a far clipping plane that is less than your near clipping plane, then you see absolutely nothing. So let's put it all the way back out there. Oh crap. So I just set my near clipping plane behind the camera. So it went from 0.1 to less than 0. So that doesn't work. So let's move it back up. Move everything back up. And here's the near clipping plane. If you put it out forward, then it only starts drawing from that point on, which is pretty neat too. When you have these terrains, you can see these really nice waves. Have a key to reset the clipping planes. You just hit R, and it'll reset it to their default values, which are 0.1 for near and 2000 for far. Program does not crash. This program does not crash. I ensure you that this does not crash unless we broke my program. Alright, so since my video just cut off, I have to go and reload this. I'm not going to do much regarding this video either. So this is using the face normals. You can see that there is some CPU usage. The CPU usage would be much higher on a mobile device. This is using a 3770K i7 desktop Z77 board. So the memory itself is also using 180 megs approximately. And we set that to run on the GPU instead, and you get a significant performance boost on the CPU because it's literally almost doing nothing. All the using display lists, it's basically drawing only on the GPU. Alright, and also if we turn on vertex normals, it does take a few CPU cycles to calculate them, but once they are calculated, it doesn't do much anymore, and it's pretty much fine. So let's move the light up. This also uses a minimal amount of memory because the vertex data, vertex normal data for vertex normal mode versus face normal mode. Face normal mode stores one normal per 30 vertices. It stores one normal per face, and every face contains 3 vertices. Whereas instead, you could just store each normal by each vertice or vertex, and that would save 3 times the memory usage, provided that all of the polygons intersected. But yeah, significant boost when you use this, and it also looks a lot nicer. So that's a good thing. I like how the GPU is drawing everything. Overall, this has been a great lab for me because I can see how you can offload the CPU's work to the GPU using display lists and VBOs. Although display lists seem to be relatively easy because it's easier to port code using that. Whereas VBOs, you kind of have to restructure your code to work around a different data structure. But yeah, if you like this video, thumbs up. If you don't like it, thumbs down. I'm gonna get a grade from probably the only person who's gonna watch this, except for me. So I believe I got all the points. If I didn't, let me know what I missed, and I'll go ahead and take a look at that. But thanks for watching.